Hello, ladies and gentlemen, and welcome back. We're looking at question 7 in this video on our Ontario Senior Math Competition. And it looks like it's just basically a trig identity. If A, B, and C are angles of a triangle, so they add up to 180 degrees or pi radians, whatever you want to say, prove that cos A plus cos B plus cos C is 1 plus 4 sine half A, sine half B, sine half C. Okay, so the angles of the triangle, I'm probably going to have to use that fact somewhere because I don't believe this is a general result. But there are some results that we might be familiar with. For example, if I've got two cosines, I can merge them together. I can add two cosines, but there isn't a general formula for adding three cosines. The regular ones, actually, because I might end up using all of them. Sine alpha plus sine beta. I know there's a sine alpha minus sine beta. Cos alpha plus cos beta. Cos alpha minus cos beta. And now it's up to me to try and remember what these are. So 2... twice sine, it should be semi-sum, cos of semi-difference. Oops, that should be a difference. The ones that double up if alpha and beta are the same have to end with cos of the semi-sum. I remember that. So this one should be the cos of, semi-difference. So this should be cos of the semi-sum. And the ones where you would get 0 for if alpha and beta are the same will end with the sine. And I know the last one's always minus 2. So it should be double, and then this one should be the other one. The ones with sines alternate. They've got a cos and a sine in them. And the ones with the cosines either have both cos or both sine. And as I say, I'm using the whether or not alpha and beta are equal, what the result should be there to determine whether or not I've got a sine or a cosine here at the end. So that's how I remember it. Okay. So for example, if we were to do cos A plus cos B, I can replace that with twice cos A plus B over 2 cos A minus B over 2. Now, what are we shooting for? We're shooting for something that's got a bunch of sines in it, but it does have the over 2's, which makes me a little happy because this is A plus B over 2, but it's also A over 2 plus B over 2. Okay, so we're starting to get our half angles in there. What else can we actually? Speaking of half angles, so I can't do anything with that. I can't then come along and add cos C and use any of these formulas because none of these expressions here are a single cos or a single sine. But I could, because it's cosine, I could trade that cos C and use a half angle formula. Now, there's a couple half-angle formulas we could use. Is there a best one? Well, we're shooting for sines. It's sine squared 2c over 2. Or, no, that's, and it should be c over 2 that way. I've got them in the wrong order. Yeah, that should do it, because this is basically just me doing the cos of the double angle formula, which is 1 minus 2 sine squared alpha. It's also 2 cos squared alpha minus 1. It's also cos squared alpha minus sine squared alpha. But I'm going with this one here and the half angle because we need c over 2's. Fine, all of these would have c over 2's. But we also need sines, and I don't have any sines kicking around yet. Okay, so what have we got so far? Cos A plus cos B plus cos C. I can trade that first little bit for a 2 cos A over 2 plus B over 2. Cos A over 2 minus B over 2. And then I've got this 1, which is great, because what is it we need? We need a 1 lying around, so we'll probably keep this 1 off to the side. I've got c over 2 there. Okay. So we'll keep this 1 safe. So now I need to turn the rest of this into 4 and then some stuff. I'm going to take out a factor of 2. Now I know a plus b plus c, because it's in a triangle, has to add up to pi. Okay, I'm using radians. I feel like because of the presence of calc on here, radians might be the best thing to do. But you know, if you wanted to write 180, that'd be fine. Now, if we divide by 2 and bring the c over to the other side, actually, let's bring the c over to the other side first. So this a over 2 plus b over 2 can be replaced with pi by 2 minus c by 2. So our cos A plus cos B plus cos C, keeping the 1 out front, I'm going to keep the 2 there. And I'm going to trade this for cos pi by 2 minus c by 2. I don't think there's anything I can do with the a by 2 minus b by 2 yet, but we'll see. And then minus sine squared c by 2. And we'll close this off. And this pi by 2 here, you got to remember cos pi by 2 minus an angle is the same as sine of that angle. So now I'll get another sine c by 2. In fact, we can take that out, I guess. And I'll be left with cos a by 2 minus b by 2 minus sine c by 2. So I brought one of those sines out when I traded this into sine c by 2. Okay, so that's good. I've got a c by 2. That's fantastic. And then what have I got left over? That needs to turn into 2 sine a by 2 sine b by 2. Well, I've got the a by 2 and the b by 2. They're, of course, trapped inside a cosine. But this sine here, this sine is not easy, because there's no difference formula for a sine minus a cos. Plus, I've also got this c by 2 here. I'd really like to have some a by 2's and b by 2's. So can I do the same sort of trick and say c by 2 is pi by 2 minus a by 2 plus b by 2? So that would change this, get rid of all the c's, which is good. I just want to be working with a by 2's and b by 2's. And then it would change the sine to a cos, and then I'd have a difference of coses. A by 2 minus b by 2 minus cos a by 2 plus b by 2. So plugging that in there, the pi by 2 would change it from a sine to a cos of this angle, the thing that's being subtracted. Yeah, okay, so that's good. And then we've got a formula for difference of coses, and did I change a sign here? No, I don't think I did. So the c by 2, and then it's minus twice the sine of the semi-sum. And then the sine of the semi-difference. Right? Okay. So that'll bring I'll get the 4 that I crave, except now there's a minus 4, so have we done something wrong? And then, so the 2 and the minus, they've gone away, and then b by 2 and the b by 2 cancel out, just like the a by 2 and the a by 2 cancel out. A by 2 plus a by 2 is just a over 2. And then we'll have minus b over 2 minus another b over 2. That would be minus b over 2, but sine is odd. So a minus sign inside can pop out. And so this minus sign and this minus sign cancel out. And we're left with what we're looking for. And I'll just rearrange it so it's the way they wrote it. And there we go, and we're done. And that's all we had to do. It wasn't prove this trig identity and do something with it. It was just, if you got the angles of a triangle, you get this nice little rule. Okay, but we had to use a lot of trig identities to do that. We had to know sums of cosines, differences of cosines as well. We had to know how sine and cosine are related. Had to use sine being odd there at the end. Was anything else major that we used? The half angle formula here for the cosine, that was good. Yeah, a lot of trig identities for that one. It's a good question, good trig-based question. You really had to know your trig for that. Okay, up next is going to be question number 8, and we'll take a look at that in the following video. Until then, take care and have a wonderful day.